And what I need for you to do is just look at, right there on the front of that packet, there are some quick reviews. And on Friday, I see people on Friday. On Friday, we're gonna have another quiz, all right? And you know how the last quiz was over the Christmas review sheet? This one will be over these quick reviews. There's 3 quick reviews. On each one, I will mark out a problem that we haven't gotten to yet, because we haven't finished the whole chapter yet. So you will be prepared when you come in on Friday for a quiz over the problems we're getting ready to review. Everybody clear on this? All right. So let's start with quick review 1. You may not get through all of them today, we'll do some tomorrow. Maybe we'll get through all of them, let's see. Quick review 1 says find arc length. All right. Who has a clue? All right, so we know that our little formula is radius times radians. That is radius times angle. Problem is the angle must be in radians. So what are we going to do first? Pi over 180 equals x over 42. And then 180x equals 42 pi. So x is 42 pi over 180. At some point we're going to have to reduce, so I might as well just do it right now. 6 goes into both of those. So 7 pi over 30. Not the answer. What is that? That's your radian measure right here, 7 pi over 30. And that is what you are going to multiply by 6. Right? So I'm going to go straight across, or I can cross cancel. Whatever flips your switch, when you reduce, the answer will be 7 pi over 5. If this had a unit on it, like 6 inches, then the arc length would be 7 pi over 5 inches. Okay, got it? Number 2. Let's solve this little equation. We talked about this yesterday. This was one of those that somebody said, whoa, that doesn't look like in the notes. Well, you did pass it.
Yes.
So that, do you remember what we did yesterday? If we get problems like this, we gotta solve it first. That's right. We gotta solve it just like a regular equation. Whoops, it's not 1 anymore. It's 2, 3. All right, so we'll subtract 1 and divide by 2. So we get cosine equals -1/2. Everybody good? Now it doesn't, oh yeah, it does. It says my answer has to be in radians. Okay, so let's think about that. Yesterday we talked about this. Don't make it hard. 30 is a 1/6 of 180, pi over 6. 60 is a 1/3, so pi over 3. And 45 is a 1/4, pi over 4. So it's going to be one of those. All right, let's see. Where is the cosine a negative number? I need cosine to be negative to the left. So I'm going to have a triangle here or here. These problems always have 2 answers. So I'm over here somewhere. The cosine, which is adjacent over hypotenuse, -1/2. So that makes this a 1/3, which means the angle is a 60, which is a 1/3 of 180. So I'm going to say pi over 3. both of these are pi over 3? Right, we just learned this yesterday, but are we following along? So now I need to know what the angle is. So one of my answers is this one. Now remember, this is pi. So the pink would be 2 pi over 3, because this is 1 whole pi. This is like 3/3. I didn't cover that 1/3 there, so that means I did cover 2/3. And then the other one would be 4 pi over 3. That's exactly right, because I went the 3/3 and then another third. Was that you, Jimmy?
That was me.
You're an amazing human being. Good job. All right, we okay? So like the last quiz, part of it will be calculator, part of it no calculator. Number 3 is a calculator question. So we need our calculators. We have a lighthouse. Here's the lighthouse. I want to know how tall it is. My angle of elevation is 23, 10, 13. So we're going to need to remember how to put that into our calculator. And I am 200 feet from the lighthouse. So this is me. I'm 200 feet from the lighthouse. Where do I put the 200? On the bottom, right? Here's the lighthouse. What would this be? Me to an eagle on top of the lighthouse? Something like that? Just say how far am I from the eagle on top of the lighthouse? All right, here we go. I need an equation. My equation will always be sine, cosine, or tangent. This one is tangent. And how do we know? Because hypotenuse isn't involved in the problem. And we have opposite and adjacent. So that equals x over 200. So x is 200 times this tangent. All right, let's make sure we all know how to type that in on our calculator. 200 tangent, 23. Remember how to do this? Second angle degrees. 10 second angle minutes. And what do I do about the seconds? 13 alpha plus. Did you get 85? What do you think? Look at the problem, Eli. So 85 degrees and 85, not degrees, 85.597 feet. Anybody else get that?
Yeah, 85. Wait, I did not. Yeah.
Number 4 is the one we are leaving off. This is section 4.7, and we're going to cover that later. So that will not be on your quiz. You do need to know how to do it eventually, but 4 will not be on your quiz. Your quiz is only over 4.1 to 4.6. Okay? So we're going to skip it temporarily. We can come back. Tangent 135, no calculator. Tangent 135 is secant pi. No calculator here. Taking attendance, does it look like, what is it?
They said the other one.
Kelsey?
It's like a light on the side. Got it.
Okay, what did you do here? Hopefully you drew a picture. Hopefully you drew it over here. Dropped the perpendicular, made a triangle. How big is the reference angle right here? 45. What do we know about the sides of a 45, 45, 90? 1 root 2, stop. We're not quadrant 1, something's negative. This guy's negative, right? We want tangent. What's tangent? Opposite over adjacent? Get negative 1?
Of course it did. Oh, so it's gonna
Cosecant pi. Alright, first thing you might want to do is think of pi as 180, right? So when I go to draw that, you don't have to, either way it's going to be right here, right?
Yeah.
I don't make a triangle, I make a circle with a radius of 1, right? And this point, here's the origin, so this point would be negative 1 comma 0. So x is negative 1 and y is 0 from that point right there. And then I just gotta remember, oh my gosh, what is cosecant? Cosecant.
Oh, cosecant. That's y over, or it's r over y.
R over y. R over y. Because cosecant is the reciprocal of the sine. And sine is the y, or the opposite side. So if sine is y, cosecant is y, just flipped over, so it's r over y. So that will be 1 over, oh, yep, that one is undefined. When we were graphing our cosecant, there was an asymptote at pi. It's undefined there. All right, so that's review 1. Let's go down to review 2. Find the exact value of the cotangent of 2 pi over 3. Now, if you want, you can go ahead and change that into degrees. So it's 2/3 of 180, or 2 times 60, however you think about it. So it's the cotangent of 120. So I know that 120 is over here. Right? I'm gonna drop a perpendicular. I gotta figure out that guy right there. He is the important one. How big is that angle? This is 120, and this is 180. This guy is 60. So root 3, 1, 2, and then I pause. I'm not quadrant 1, so there's a negative in there somewhere. Right here. Now what cotangent? Cotangent is adjacent over opposite because it's the reciprocal of the tangent. So negative 1 over root 3 is the cotangent. But we're not doing 2, we've crossed 2 off. And again, we're not crossing 2 off because you don't know, you don't have to know how to do it. It will not be on this quiz. You're going to learn how to do that. We kind of already know most of it, but there's a little piece we haven't talked about yet. All right, number 3. With a calculator, 3 tan minus 1 equals 0. And again, we are solving in tells me that my answer is going to be in radians. So since I'm using my calculator this time, I'm going to change to radians right now. Okay? Everybody okay? Doing that? Alright, now let's solve it. So we're going to add 1 and divide by 3. Is everybody okay with that?
So here's.
And then I stop. There will be 2 answers to this problem.
1 and 3.
Quadrant 1 and quadrant 3. Now I don't think there's any question about why I know tangent will be positive in quadrant 1. That's a positive number.
It's double negative.
But in 3, opposite and adjacent are both negative. So there we go. Now the reason we need a calculator, we did one of these earlier without a calculator. The reason we need a calculator is this, right? And that is not one of our special triangles. This would be a root 10, okay? That is not a special triangle. So I don't have it memorized, so I have to use a calculator, all right? I still need the picture though, because the calculator is only going to give me one answer and I need to figure out the other one on my own. All right, so here we go. I need to know the angle that has a tangent of 1/3. So I am going to type in this on my calculator. So I'm in radians, second tangent, 1/3. I got 0.322.
Wait, I have a question. Why did you do the -1 if you're looking for the tangent? I thought that was.
No. I am looking for the angle that has a tangent of 1/3. I know the tangent, I don't know the angle. You see the difference? Yeah. All right, so one of my answers is 0.322. Everybody get that? Now we have to figure out the other one. Remember, we always start here and all the way around to here. How am I going to figure out what that blue angle is? Pi plus, very good. So I'm just going to take that guy right there, and I'm going to add pi to it, and I'm going to get 3.463. Right? Everybody got it? Okay, number 4. Oh, this is a little bit unusual. This looks like an arc length problem, but am I finding the arc length? No. We could find the arc length doing what we did before, but this we don't need to. This would be easier not to. We want to find the area of this piece of pie. That's called a sector. We want to find the area of that sector. Okay? Now this is easier than you can imagine. What is the area of the whole circle? Pi r squared. So for the whole circle, the area would be 4 pi. Right? Now I want you to think about this for a minute. What if I took that circle and I said, find the area of that sector? What would you do? That's just a fourth, right? It's a fourth. Why is it a fourth? Because 90 over 360? Well, I don't want a fourth of the circle.
105.
Exactly. I want this fraction of the circle. Would you agree with that? And that fraction of the circle, I am simply going to multiply 105 over 360 times 4 pi. So the fraction of the circle I want is 105 over 360. I know the whole thing is 4 pi, so I want that fraction. So how you do, I mean, this is horrible one, so I don't know. I know things reduce.
So this is no calculator.
This is no calculator, yeah, this is no calculator. So, I'm gonna go ahead and take 4 into 360 and get 90 down here. So now I'm 105 pi over 90, I cross canceled. Now I know I can take 5 into both of those. So 5 will be 21 pi over, what's 90 divided by 5? 18. 3 will go into both of those, so 7 pi over 6, I think I'm done. And if I had a unit, which I don't, I'll make it inches, this would be square inches. Okay? Everybody clear on that? Next time you see it, the radius will be a different number, but that won't matter. That will just change the area of the whole circle. And the angle will be different, but that won't matter. You just put it over 360, right? Okay. Number 5, find the height of a tree. This will be a calculator problem. Find the height of a tree. Angle of depression of a bird in the top of the tree looking at a worm on the ground is 52 degrees.
Is that 85 inches?
85 feet.
Oh.
Okay, so a bird in the top of the tree looking at a worm that is 85 feet from the bird.
So it's the hypotenuse.
That's the hypotenuse. Because the worm is 85 feet from the bird.
So it's,
Does that make sense to everyone, that that would be the 85 on the hypotenuse? So sine, cosine, or tangent? Sine 52 equals opposite over hypotenuse. Multiply by 85.
85 sine 52.
Type it in. Now wait a second, that's a degree measure. Yep. I need to switch it back. That's a degree measure, right? 52 degrees. Make sure you're in degrees. So 85 sine 52. I got 66.981 feet. Everybody keeping up okay? All right, let's move on. Quick review 3. Write a sine and a cosine equation for this picture. All right. So when you look at it, what do you see? When you look at it, does this look like a sine or a cosine to you?
Sine.
Sine? Me too, because I see this right here. That's what I see. I know it goes on more. But isn't that solid part a sine curve? So I'm gonna start, it doesn't make any difference. I'm gonna start by writing a sine curve. I remember that there are really 4 adjustments that I can make to my sine curve. The adjustments are, I can stretch it vertically, that's this number. I can change it horizontally, that's this number. I can move it sideways, that's this number. And I can move it up and down, that's this one.
This one's
Okay.
two.
So, let's look at what we've got. If I think of this as a sine curve, it clearly has an amplitude of 2. Would you agree with that? And because I'm looking at the hill and then the valley, that's a positive 2. It's not starting at the origin though, it's starting back here, which means I'm gonna have x plus pi over 6. That will back it up pi over 6, right? And since it's going up and down too, there hasn't been a vertical shift. You'd have a vertical shift if it bounced back and forth between 3 and -1, or something like that, but it's balanced. So there's no vertical shift, it's bouncing right across the axis like it's supposed to. Now, the only thing that I have left is this guy. All right, I'm gonna call it N for a moment. And I know that the period of a sine curve is 2 pi divided by that number. Whatever number is in this spot divides the period. The period is 2 pi, normally. So I know that my period, I don't know what N is, but I know my period is what? How far is it from -1/6 to positive 3/6? 4 pi, 4/6? 4/6? So 4 pi over 6 is 2 pi divided by something. This right here is the period. I know that to find period of a sine, I do 2 pi divided by the x coefficient. So my period is 2 pi divided by n, so I'll cross multiply. 4 pi n equals 12 pi. I divide by 4 pi because I'm trying to figure out what n is, and what does n work out to be? 3. That number will be positive always. Now, the good news is, only one number is gonna change in this equation. The amplitude is still gonna be 2. The period is still, it's not changing, so that number's still gonna be a 3. And I haven't lifted it at all, so that's gonna be a 0. The only thing that's changed is the part of the graph I look at if it's a cosine. Well, if it's a cosine, don't I start up here?
Yeah.
This would be my cosine, do you agree? Well, wait, isn't that where he's supposed to start? So there hasn't been a horizontal shift for the cosine.
So we just don't worry about that pi over 6.
No, we only need one period to look at. So anything before or after that doesn't matter. All right, everybody got that? It's a lot there. Just remember, when you go to write your second equation, that is the only adjustment you're gonna make right there. Okay, number 2, we're skipping for the time being. Number 3 is yesterday's lesson. So the question says, find the period of this big ugly equation. Okay, so what is the first thing we do?
Gotta get rid of.
We find the period of each piece. So what is the period of this? 2 pi divided by 2? Remember, this number divides the period. And what is the period of a sine? 2 pi. So this one is pi. This period is pi. That means every pi he repeats. Now, what's the period of this one? 2 pi divided by 1/3, which is 6 pi. which means every 6 pi, he repeats.
So that means it's 6 pi.
The period is the first number both lists have in common. We call it the least common multiple. So what is the first number both lists would have in common? 6 pi. So the period, the answer to the question is 6 pi. Got it? Okay. Number 4, find a negative angle coterminal with negative 10 degrees. Okay, so yep. How do we find coterminal angles? Add or subtract a revolution. If I am in degrees, a revolution is 360. If I am in radians, a revolution is 2 pi. So negative 10 is my starting point. I am going to add or subtract revolutions. Now clearly if I add, I'm going to get positive 350. And this particular question says I want a negative answer. 350 is a coterminal angle. It's just not a negative one. So the answer to this particular question would be negative 370. Now, for some reason, some of us get all blackled if we do that in radians. So let me just step over here. Let's suppose the angle had been negative pi over 10 radians. I would add 2 pi, or I would subtract 2 pi. If it said I need a negative 1, I would do this, right? This is like taking negative 1/10 and subtracting 2 over 1. What do you have to do? Get a common denominator. So the answer would be negative 21 pi over 10. All right. Oh, this says with a calculator, find the sine of 5 pi over 12. Okay, I can do that. What mode should I be in? Radians. So sine 5 pi, use your pi button, divided by 12. Did you get 0.966? You should have. So sine 5, use your pi button, divided by 12. Everybody get that? Okie dokie. One more. In which quadrant is my angle if the secant is negative? I'm going to write it that way. Less than 0 means negative. Would everyone agree with that? And the tangent is also negative. Alright, so I'm just going to think about this. I know in quadrant 1 I'm positive.
3.
Okay, so here are the signs of x and y in all my quadrants, right? I know that tangent is y over x. If that's going to be negative, it's not happening here or here. Would you agree with me? So this part of the problem rules out those 2 quadrants. Now what about secant? Secant is the reciprocal of cosine. Cosine is which letter? X or Y? X. Guys, remember, think about your triangle. Isn't this the adjacent side?
Yes.
It's also the x side. Cosine is x. So I need x to be negative. Well, of these two options, the only place x is negative is here. So the answer to the problem is quadrant 2. Got it? All right, hang on to that. That's your practice. When I write this quiz, I'm gonna make up problems like the ones on here. And all of those. Okay. Yep, get your notes out. Our quiz is not until Friday, so tomorrow, if someone were to actually practice some problems and come in and say, hey, can we do one more like this? Maybe we can do that tomorrow. But that's on you, right, to do a little study. All right, we're now in section 4.7. And we're gonna find the exact value in radians. Okay, when you see the word exact, that means no calculator. So my answers are going to be found by hand with pictures and stuff, and an answer in radians. If I am doing a problem without a calculator and answering in radians, then I know my answer is either going to be pi over 3, because that's 60, pi over 6, because that's 30, or pi over 4, because that's 45. Right? That's it. All right, so what have I got? The angle, remember, this means find the angle. So this is find the angle whose sine is root 3 over 2. You have all seen that button on your calculator, right? When you use, we're not doing our calculator right now, but when we do it, how many answers does my calculator come up with? 1. Okay, 1. When we see this notation, that specific notation, this is one of the quirks that just gets all confusing. But when we see that notation, there's only one answer. Okay, there are lots of angles that have this sign, but we can only find the one that our calculator would find. So, when we are doing this notation, or this notation, there will be one answer. If the number is positive, like this one is, then we will draw our triangle in quadrant 1 every time. So no matter if it's sine, cosine, or tangent, we're gonna draw one triangle when we see that notation, and if that's positive, it will be in quadrant 1. The sine is opposite over hypotenuse. Do you recognize that angle? 60. However, I'm in radians, so I won't say 60, I'll say 1/3 pi. Pi over 3 or 1/3 pi is the answer to the question. Now, some of us are a little bit still trying to figure that out. Remember, pi is 180. So what fraction of 180 is 60? Isn't it 1/3? That's why it's pi over 3. All right, next one. The angle whose sine is -1/2. Remember, this means find an angle. That notation always means find an angle. But this time, the angle is, the number is negative. This is where things get crazy. If it's a sine or a tangent and a negative number, Then you're gonna look in quadrant 4. If it's a sine or a tangent, you are going to draw your triangle in quadrant 4. If it's a cosine, and we'll do one here maybe, hopefully at some point. If it's a cosine, you draw it in quadrant 2. Now there are reasons for this, I'm not going to go into them. These are the rules for this notation, this kind of notation. Anytime it's positive, you're in quadrant 1, nothing, I mean, that's easy. When it's negative, sine and tan are in 4, and cosine is in 2. All right, so what do we got here? Opposite over hypotenuse is 1/2. So you should be recognizing this as a 30-degree angle. So in radians, that would be a 6. So pi over 6. But I gotta be careful. It's not pi, the answer can't be pi over 6, because wouldn't pi over 6 be up here?
Yeah, so it would be 5.
So it's negative pi over 6. Negative pi over 6. I know it's confusing. Somebody's gonna say, well, wait, couldn't that be 11 pi over 6? And the answer is yes, but we want the smallest angle we can say. Your calculator is gonna come up with the smallest one. So negative 30 is better than positive 330 with this notation. Jimmy, you look like you're like, oh my gosh.
I'm good with
You're
long
good.
class, you know.
All right, let's see. C. Find the angle whose tangent is 1. I like to think of that as 1/1. All right. Okay, I'm not sure what's happening here. My, you know, my siblings. Okay, so first thing I have to figure out is which quadrant am I drawing it in? I'm drawing it in quadrant 1. If that number is positive, I'm in quadrant 1 no matter what. Tangent is 1/1. You should recognize that triangle.
30. 30.
45.
Whoa.
1 root 2 is a 45, isn't it? It's okay, Jimmy.
Tired.
I know.
Pi over 4.
And the radian measure is pi over 4. Positive pi over 4. Because we're answering in radians. Now, the next one is a little bit wild. We draw a circle. How come we draw a circle? Because that's the only way you're going to get a 0. Think about it. Can you draw a triangle and have a 0? No. So the only way we're going to get a 0 is to draw a circle. Our circle is going to have a radius of 1, and so I'm going to look at all these points now because I don't know which one I want. But I want the first one that has a cosine of 0. Now, what is our definition for cosine? X over R? So if I want that to be 0, won't it have to be 0/1? So start right here, going around our circle. Does this have the right X value? No. Does this have the right X value? Yep. So there's your answer right there. In degrees, that would be 90. In radians, it is pi over 2. Now we're just gonna type, oh wait, the first couple are easy, that last one's a little tricky. Well, let's go ahead and do the first one. So use your calculator, round to the 10,000 in degrees. So I need to go back to degrees, as that's what the directions say. Second tangent, negative 1.43. Negative 55.0349. Does it say 10,000? Everybody good with that? Second sine, 0.761. I got 49.5524 degrees. Now, this is where we have to be careful, all right? I want everybody just to stop for a second. This is where we have to be careful. Okay? This says, literally, it says, find the angle whose cosine is 1.98.
Because it's the same thing.
So in other words, the cosine is 198 over 100. Would you agree with that? I just stopped. I haven't done anything yet. I'm just reading the problem. It says find the angle. Oh, whose secant, I'm sorry, it says secant. Whose secant is 198 over 100. Find the angle whose secant is 198 over 100. If the secant is 198 over 100, then the cosine is 100 over 198. So what I'm going to type into my calculator is this. We never, ever do 1 over these.
You get an error.
Yeah, did you get an error? So you'll catch yourself if you try it. Instead, you have to think about, okay, this is describing an angle, and the secant is 198 over 100, which means the cosine is 100 over 198. So you should have gotten 59.6653. So the answer to problem C is 59.6653. Okay? All right, let's try a couple more. Find the exact. What does exact mean? No. It means without a calculator. All right, so we're going to do this without a calculator. And I know what you're thinking. You're thinking, what? Is it okay if I write my problem like that? All right. Temporarily, I'm gonna get rid of that because I know from PEMDAS, 3rd grade, that I start inside the parentheses. That's where I start. So I'm gonna draw a picture of the angle in quadrant 1 because that's positive and I just erased my rules. But anytime you have that notation in a positive, it's in quadrant 1. And opposite is 1 and adjacent is 10. Okay? Now, can I find the hypotenuse?
Yeah, just do.
What will it be? The square root of something. A squared plus B squared equals C squared. So the square root of what? 101. Now, Exactly. Do I have any idea how big that angle is? No idea at all, and I don't care, because remember, I am finding the sign. I'm not finding the angle, I'm finding the sign. Can I find the sign here? Yep, it's 1 over the square root of 101. No, 1 over the
Oh,
square
but I
root
thought
of
we had to,
101. No,
we don't have to fix that.
leave it. Leave it. Okay? Now, just to show you, we know what we're doing. Type this on your calculator. So you can just type it in, just type sine, second tangent, doesn't even matter, 0.1. So sine, second tangent, 0.1. Did you get 0.0995, da, 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 da? All right, now, type this in. 1 divided by the square root of 101. Same thing.
Holy
So
crap.
this is the rounded off answer, and this is the exact answer. Doesn't matter. This one, it doesn't matter, because you are not inputting or outputting an angle. All right, one more. Find the secant of the angle whose sine is 2/3. We're doing this by hand. So we start by drawing a picture in quadrant 1. I am in quadrant 1 because that number is positive. The sine is 2/3, opposite over hypotenuse. Then I find the other side. Yep, Pythagorean theorem. Please do not say root 13, that will be wrong. 2 squared plus b squared is 3 squared. I think it's root 5.
Yeah.
Now I want the secant of that.
Cosine.
That's reciprocal of cosine, so it would be root, no, 3 over root 5?
Yeah.
Would be my answer.
Famous?
Alright, I'm gonna stop there.
I like those.
You must be famous.
I was gonna say, wait, I'm not.
Oh, wait.
Even if you want to find it out there.
They all have jobs. They have jobs. They have jobs all day.
It's